Greetings everyone. In this video, we'll learn about how to design a dog bone shaped geometry suitable for tensile testing. Since we are going to test it for 3D printing this polymer, I'll follow a certain designation defined for tensile testing of polymers. The standard followed for polymers is designation D638. You can have a look at this document and know more about the standard test methods for tensile properties of plastics. But to build the geometry, I'll go to the geometry section, and based on the properties of your material, you can select which type of structure would you like to print or use for your tensile testing. For this tutorial, I'll use the parameters defined for type 1 geometry. To start constructing this geometry in COMSOL, I'll first define parameters as mentioned for the type 1 sample here. To do that, I go to COMSOL and go to the tab parameters. Then in the tab parameters, I'll define all my values. To build this geometry, I'll first consider this geometry into 3 rectangular sections, one with a length of L and the other two with a length of L0 minus L upon 2. To do that, I go to COMSOL, navigate to Geometries, and right click to start building a block. Then I define my dimensions and go to build. After that, I'll also define the outer blocks, and you can do that by defining the dimensions in the tab size and shape. You can also adjust the position of your cuboid or rectangular section by defining it in the tab position. Once you have your 3 rectangular sections, the next step is to provide this arc of radius capital R. To do that, I'll construct 4 circular arcs here at the intersection point of the sections, and I'll use the operation difference available in COMSOL. To start it, I go to the tab Geometry, right click on it and select a cylinder of thickness similar to the blocks. For cylinder 1, the thickness is T and similar for all other cylinders. I will construct this cylinder by clicking on the tab Build Selected. And you can also adjust the position of the cylinder to make sure that its center coincides with the intersection of these two cuboidal sections. Similarly, you can construct cylinders for all remaining 3 arcs. Once you have done it, go to the tab Geometry, right click on it and choose the option Booleans and Partitions, and then navigate to the tab Differences. We want to subtract the cylinders from the blocks, and hence we need to select the domains for both these tabs here accordingly. In the tab Objects to Add, I'll select the rectangular sections, and in the tab Objects to Subtract, I will select all the cylindrical bodies. There are several options available for the function differences. You may play with them to understand the difference in their functionality. You have the geometry you wanted, but still there are things to consider, such as you constructed these 3 blocks separately but never joined them, whereas if you are going to print it, it will be printed as one single entity. Hence, we should also signify it in the model here. Use the option Form Union to unite all 3 blocks to consider the complete geometry as a single entity. Once you do that, the next step is to ask COMSOL to ignore these faces in the middle of the geometry. To do that, right click on Geometry, go to Virtual Operations and navigate to the tab Ignore Faces. Then you can select the faces that you want to ignore, and their respective number will appear on the window input. Go to Build Selected and ignore the faces. Similarly, you can also ignore the edges that you don't want. And finally, click on Build All to build the geometry. If you want to perform further simulations on this geometry, you may assign the material properties to the sample select the physics that you want to apply, create a mesh, and then perform a study. But if you just want to export it as an STL file to 3D print it, follow the same procedure as explained in the previous tutorial. Thank you.